Hello everyone, myself Shankar Phulwale, Assistant Professor Department of Chemistry, KN Vise Arts, Commerce and Vinayagara Patil Science College, Vidyanagar, Bosri, Kurwadi, Solapur, Maharashtra. Today I am going to represent the seminar on NMR spectroscopy. The content of NMR spectroscopy is shielding and deshielding. So first of all, what is meant by shielding and deshielding? Then the induced magnetic field. In organic compound, protons are covalently bound to the carbon, nitrogen, oxygen, etc. It have paired spin electrons and have no net magnetic field. But under the influence of applied magnetic field, additional modes of circulation of electrons are in. The circulation generates its own magnetic field is known as induced magnetic field, which is shown in the figure. So induced magnetic field, which is depends upon the two factor. First is electron density and the second one be the applied magnetic field. So greater is the electron density, greater is the induced field. Greater be the applied field, greater is the induced field. The induced field, that is H induced, is directly proportional to H0. H0 means applied field. So H induced is equal to sigma H0. Sigma is the shielding parameter. Those protons which having the same chemical environment are known as equivalent proton, and those protons which having the different chemical environment are known as non-equivalent. So induced field, which is depends upon the electron density. Greater is the electron density, greater is the uh, downshield. So downfield shift. So which is shown into the examples. That is the shielded or deshielding order of protons. So there are some illustrations are discussed under chemical shift concept. Although electronegativity consideration are prominent, but the other powerful shielding and deshielding mechanism discussed. The mechanism which is based on the again two factors effects. First one be the van der Waals deshielding. Proton occupying a sterically handled position in a rigid molecule is deshielded proton. The example of deshielded protons are highly substituted steroids. Second one be the anisotropic effect. Anisotropic effect means circulation of pi electron under the influence of applied field generates induced field, which is generally stronger than the generated by sigma electrons. So it can augments with the external applied field. So these protons are known as the deshielded proton. It is also known as paramagnetic shift or downfield shift. So other it can oppose. So it is known as the upfield shift or diamagnetic protons. So this is the anisotropic effect shown into the benzene. So in case of benzene, the at the center, so induced magnetic field opposes to the applied magnetic field. So the proton comes under these regions are known as the shielded proton. And if it augments with the applied magnetic field, so proton comes under in these regions are known as the deshielded proton. So in benzene, there are 6 proton and all 6 protons comes under the deshielded region. So second example of deshielding is alkene. Again, in case of alkene, there are 4 proton and which comes into the deshielded region. So the protons which is present into the alkenes are the deshielded proton. Third one be the anisotropic effect in aldehydes. So in aldehyde at the center of carbonyl group, that is the oxygen, it generates one cone and the proton which comes under the cone are deshielded proton and aldehydic protons which comes under the cones. So it is highly deshielded proton. It shows the value approximately 9 to 11 delta ppm. So last one be the anisotropic effect in alkynes. In case of alkynes, the protons, the structure of alkyne is linear. So the proton comes under these regions, that is the deshielded region, because the applied magnetic field opposes to the induced magnetic field and the proton comes under this region. So these are the different values, that is the chemical shift values of different type of proton. First one be the CH3 proton, which shows the lowest values. Then CH2 proton, CH proton. So there are different type of proton which shows the different chemical shift values, that is which is expressed in delta ppm. So the minimum value, that is the which starts from the zero point 0.7 to 1.3 delta ppm, and I think highest the value, that is acid or enol, that is 14 to 16 delta ppm. So again there are different examples. So first one be the methyl proton. So methyl proton shows the value that is zero point 0.9 and it increases in case of ester that is 3.7 and aromatic that is dinesolo etc. It shows 3.8. Second one be the methane proton that is the CH2 proton. The value of CH2 proton which is greater than the CH3 proton. And finally the CH proton that is the methane proton. Methyl proton shows again higher value compared to the methylene and methyl proton. So aromatic proton which shows the higher value that is the 7.3 delta, aldehydic proton which shows 9.7, acidic proton which shows the 11.0, etc. So this is all about the shielding and deshielding. Okay, thank you so much.